Hello, this is the first quarter final review for Algebra 1. Let's get started. First, we're going to do unit conversions. So Tanya's dachshund puppy can sprint a speed of 15 feet per second. Okay, what is the speed of inches per second? Okay, and we know that 1 foot is 12 inches. Okay, so 15 feet, let's write this down, 15 feet. Okay, per second means every second for every 1 second. So it means over seconds. So we got to always associate that per with being on the bottom. Okay, we want to make it into inches per second, which means we want to keep the seconds, but we want to convert the feet. So we got to multiply one time, because only one conversion, one multiplication, and since we want to cancel the feet out, we don't want to have feet in our answer. We want to put feet down here, and then we have feet on top, feet on the bottom. They cancel just like a number would when you have the same number on the top and bottom. So feet go on the bottom, which means inches go on top. Okay. And then we can fill in the values that they give us. 1 foot is 12 inches. And then again, the units will cancel, and you can see that we have inches left on top, seconds on the bottom, or inches per second. Okay. In a sense, it just comes out to what 15 times 12 is, but this is the format you want to use because it works for any level of unit conversion problem, even easy ones and some of the harder ones. So 15 times 12 is 180. And we have inches per second. That's D. Number 2, which of the following represents a quantity measured in feet per second? So basically, after the units cancel out, are we left with, again, feet on top per second? Very important to translate. So this is what we're left over with, feet on top and seconds on the bottom. So we go through this top one. We have yards on the top and bottom. Those cancel. And we have minute here and minute here, so those cancel. And we're left with feet over seconds, so yes. And we'll just do the same for each one. Yards on top, yards on the bottom. Minutes on top, minutes on the bottom, or on top, bottom and top. And feet left over, and seconds, feet on top, seconds on the bottom. So again, that's a yes. The third one, let's see, there's nothing that's the same on the top and bottom, so nothing cancels out, so no. And here we have, let's see here, minutes and cancel out, one on top and one on the bottom. And here we have yards over feet left over, but we want feet over seconds, so no, that doesn't work either. So just seeing what cancels and is what left over is what we want here, feet per second. Okay, convert 3 meters per minute to centimeters per hour. So here's where we definitely want to use the dimensional analysis that we did earlier, number 1. So start off with this, 3 meters per, or for every 1 minute. I use M for meters and MIN for minutes so we don't get confused. And you'll notice that we're converting two things. The meters are going to be converted to centimeters, that's the distance. And the minutes is going to be converted to hours. So we have two conversions, so I need to multiply twice. So it's going to look like the expressions in number 2. So first let me do the meters. Again, in order to get them to cancel out, I have meters on top, so I'm going to put it down here so they'll cancel out, which means centimeters have to go on top. Notice how the distances are together. So you're going to have one conversion for the distance, converting meters to centimeters, and then you'll have another one converting the times, which is minutes to hours. So we have minutes on the bottom, so to cancel it out, I'm going to put minutes on top, and then hours on the bottom. So you have time here. So the first step is really to set up the units in the proper way to make sure they cancel out. Now it tells us that we have 1 meter is 100 centimeters. I'll put a 1 down here and 100 up here. And then over here we have to just know this, not written here, but we have to know that 1 hour is 60 minutes. So what we have here is really just 3 times 100 times 60. And then all the units, the minutes cancel out and the meters cancel out, and we're left with centimeters over hours or centimeters per hour. Okay, so 3 times 100, 300. 300 times 60, well, 3 times 6 is 18, and then we'll have 3 more zeros. 1, 2, 3 more zeros. So we have 18,000 centimeters per hour. There we go. And number 4, which is equivalent to 22 minus 2y. Okay, let's just go ahead and distribute. We have 22 minus 2y. That one's a yes. Here we have 11 plus 11. That's 22. Negative 1y and negative 1y. Negative 1 and negative 1 is negative 2y. So that's a yes. Okay. Here we have negative y and negative y again, like above in B. That's negative 2y. And we have 26 minus 4, which is also 22. So these are all yeses. Okay, let's continue with number 5. Okay. All 3 triangle, this is all proportion sections. Okay, so all 3 triangles are similar, which means same shape, different size to each other. Set up and solve 2 proportions to find x and y. Okay, so we got to do 2 things. We got to set up and solve. So first, this is the triangle with x. This is the triangle with y. The middle one only has numbers, so I'm going to do 1 proportion with these 2 to figure out a proportion just with x's, and then I'm going to do another proportion with these 2 because those will only have y's. So first the x's, and I'm going to do height over base. So I'm going to do height would be 5x over 1 over the base, which is 2x. And I got to do the same thing for both of them. So the height here is 6. And the base is, height is 6, the base is 4. Okay, and we can go through and solve that. We'll have multiply these 2 together, and then multiply these 2 together. So we'll have 4 times 5x minus 1. And 6 times 2x. There we go. Okay, and we can solve that. 20x minus 4. Okay. And I can subtract 20x on both sides. So negative 4 equals negative 8x. And see, 8 times what is 4? Let's divide both sides by negative 8. Negative 4 over negative 8 equals 1/2. X is 1/2. Okay. And then we can do the same thing for y. Let's see here. Same thing, height over base. 11 minus y over 3y, 6 over 4. Go ahead and multiply those together. We have up here 4 times 11 minus y equals 6 times 3y, or 3y times 6. Okay, so let's distribute. We'll have 44 minus 4y equals 18y. Add 4y both sides. So 44 equals 22 times what? And just by dividing, you can see that y equals 2. There's our two solutions for x and y. Let's do a little solving of equations now. Doing some equations. So let's do some distributive property. 6x minus 6 equals 6x minus 1. And when we begin to solve this, you can probably be suspicious ahead of time that they're the same variable and coefficient on both sides. So when we subtract 6x on both sides, you're left with negative 6 on the left and negative 1 on the right. And when there are no variables left over, that's when we have the special cases. So this case is false, because negative 6 is not equal to negative 1, and therefore no solution. And below, number 7. See, we got some parentheses. Let's start here first. Distribute the negative 3. So negative 3n, negative 3 times 4. Bring down everything else. Bring down the 4 equals, let's go ahead and combine these two. 7n minus 4n is 3n plus 3. Back to the right side, you can see you have a 4 and a minus 12. Okay, so negative 12 plus 4 would be negative 8. So now we have negative 3n minus 8. And just brought this down and combine the negative 12 and positive 4. You get negative 8. Bring this down, stays the same. And when we go and solve this, add 3n to both sides. Subtract 3 on both sides. And you might be suspicious, like, well, this is 3n, this is 3n, so shouldn't it be no solution? But this is a negative, so it's not the same thing. Like up here we had positive 6 and positive 6. That's why we had a no solution. But here we just have 3n plus 3n, which is 6n. 0 equals 0. Negative 8 and negative 3 is negative 11. Divide both sides by 6. And n equals negative 11 over 6. And just please leave your answer just like that. Don't make it a decimal. Don't make it a mixed number. That's fine for your solution. Okay, number 8. More with equations. Just find which steps did Maddie or Michael make a mistake. So maybe one of them made a mistake, or maybe both of them. Let's see what they did. So first we got to distribute 2/5 times 2. 2 times 2 is 4. And then it should be 4 over 5, but this one is 4 over 6. So it looks like you already have a mistake here on step A, because that should be a 5. If you continue on, you might find some more, but 4, 6, yeah, I think that's it. Since it's already a mistake, everything will be wrong after that. That was pretty easy. Just catch the fractions on the first one. Over here, it looks like the first thing they did is multiply by 5/2 on both sides to cancel it out, which is fine. That's an okay step. So those cancel and equal 1. Those cancel equal 1. We're just left with 2x minus 5. Let's see here. 2 goes into 6 3 times. 3 times 5 is 15, so that's good. Add 5 on both sides, and we get 20. That's good. And then divide both sides by 2, or take half of both sides, and that's good as well. So it looks like that one is okay. All right, let's go on to page 2. All right, so inequalities. So the only thing different with inequalities is that it's just like equations, but when you divide or multiply by a negative, you got to flip the inequality sign. That's the really main difference, and then we'll get into some differences for graphing later on. But here we just have to get the variables on the same side, so I'm going to subtract 2/3 x both sides. Okay, there are other ways of doing this. I'll give you the same answer, but this is the most direct way. So we have 0, bring down the 1/2, bring down the less than or equal to. 1/3 minus 2/3 would be negative 1/3. And if we multiply both sides by the reciprocal, 3 over negative 1, we'll get our answer of, those cancel out, negative and negative are positive. So notice how the x is on the right hand side. So I'll have x on the right hand side less than or equal to 3 times 1 over negative 1 times negative 2. Oh, sorry, negative 1 times 2. So we got negative 3 over 2. Okay. And which is the same thing as negative 3/2. Notice how when I flipped it around, how this opens up to the variable, okay, and it's still doing that. Okay, good. Let's go down to 10. Which is the could be correct? Which of the following could be a correct first step to solve this? All right. Distribute the negative 2. That seems like a good step. So we can try distribute the negative 2, and we'll have negative 2a minus 16 greater than 18. So that looks like not A, but B. And below they say you can multiply both sides by negative 1/2. So let's try that. We multiply this by negative 1/2. I'm just going to rewrite it over here in the corner. I multiply by negative 1/2. That would cancel out this negative 2. Multiply this side by negative 1/2. I'd just be left with a plus 8 greater than negative 9. 18 times negative, half of 18 is 9, and then with the negative we have negative 9. And looks like that would be C. D has the sign the wrong way. Or no, it doesn't. Oh, wait a minute. We multiplied by a negative, didn't we? So yeah, we do need to change that sign. So glad I caught myself. So definitely got to change the sign since we multiplied by a negative. There we go. Very tricky. Number 11. Compound inequalities. So this is an between statement, so we know our graph will more likely be something that is connected in some sorts. And that just, I know it just by looking at this type of inequality. So we can do this two ways. We can solve that inequality, 6 is less than or equal to x minus 2, and then we can solve this inequality. X minus 2 is less than 14. So we have 6 is less than or equal to x minus 2. Add 2 to both sides. 8 is less than or equal to x. And now we can do x minus 2 is less than 14. Add 2 to both sides. So x is less than 16. Combining these together, that means these are all the numbers between 8 and 16, including 8, because that has the equal to. So I'm going to put an 8 right here, solid dot, because of the equal to. And I'm just going to put 16 over here in an arbitrary place just away from it. Open circle, that's strictly less than, and then connect those two. Remember, this is called a between statement, meaning all the answers are between two numbers, 8 and 16. All right, continue on. Do a little solving. Divide both sides. We'll have negative 5n, 0, negative 10. And again, we're dividing by a negative. We get a lot of practice dividing by a negative. So we'll switch this to greater than or equal to 2. And it is a solid dot because it's an equal to, and we're everything greater than 2. Alright, let's start on the right hand side on this one. X plus x is 2x plus 1. Just going to do one step per line. And when we subtract 2x on both sides, we're left with 7 greater than or equal to 1. That's 7. Is this true or false? Is 7 greater than or equal to 1? Okay, or another way of saying is 7 bigger or equal to 1? And that would be a true. That's definitely true. Therefore, all real solutions. If this happened to be a less than, it would be false. So true and false determine the. You want, for true, you want the all reals. For false, you want no solution like we did on the front. Let's go to 14. And or. So in all likelihood, this graph will be like going different opposite directions, like opposite of and. And if we solve each one of these, we'll have x is less than 12, or, write that in, or, if we add 6 to both sides, x is greater than 19. So 12 and 19, both open circles. I'll arbitrarily put 12 right here, and we'll put 19 right here. And it's everything less than 12, that's to the left. Everything bigger than 19, that's to the right. Okay, so which one of these are actually solutions? It's -4 in this area on the left, or this area on the right. Okay, yeah, -4 would be over here somewhere, so that's a yes. 12. 12 is right here, but it's an open circle, so 12 is not an actual solution. 15 is between, so no, that's not a solution. And 22, which is over here, that is bigger than 19, so that is a solution. Okay, number 15. All Alright, Letitia is on page 30 of her book and reads 3 more pages every night. Sal's on page 40 of the same book and reads 2 more pages every night. How many nights will it take for Letitia and Sal to be on the same page? So define our variable. What are we trying to find out? It might be tempting to say pages, because they keep on talking about pages, but if you read the last question, it usually gives away what they're looking for. So right here, how many nights will it take? So our variable and what we're trying to figure out is how many nights. So I'm going to use n for nights. So gotta read this carefully. Okay, write an equation. Okay, so Tisha starting at 30 and 3 more pages every night. So there's our variable again, 3 pages every night. And that's going to equal, Sal's going to start on page 40, but he's going to only go up by 2 pages every night. Okay. And when we solve this, let's see here, subtract 30 on both sides, and subtract 2n on both sides. We'll have n, number of nights is equal to 40 minus 30, that'd be 10 nights, and that equals 0. So after 10 nights, okay, explain a sentence. After 10 nights, Letitia and Sal are on the same page. There we go. You might notice this looks very similar to a y equals mx plus b or a linear equation, okay, with the y-intercept and a slope. The y-intercept and the slope very closely related to everything else. Okay, number 16. A volleyball team scored 14 points more in its first game than its third game. In the second game, the team scored 28 points. The total number of points scored was 80. How many points did the team score in each game? Okay. Let me jot a few things down. This is not one just to easily start writing the solution to. So what do I know? We have 3 games. A first, second, and a third. So before I get formal, I'm just going to say something like this. There's a first game, second game, and a third game. And we know it adds up to 80 points. So that's pretty certain. And we're trying to figure out how much we scored in each game. Okay. So let's see here. Read this again. The second game, the team scored 28. So that's pretty straightforward. It looks like the second game is 28 points. So, you know, they just say that in the problem itself. So we're really dealing with the first game and the third game and trying to figure that out. Okay. So, what do we know? The volleyball team scored 14 more points in the first game. So the first game right here is going to be the third game's points plus 14 more. And we don't know what the third game is, so there is our equation. All these different games, the first, second, and the third, all add up to 80. Now we can solve this. T and T makes 2T. 14 and 28 makes 42. Okay, subtract 42 on both sides, we'll end up with 38. And divide both sides by 2, and T will equal 19. So remember, T is our third game. So now we know that third game is 19. points in game 3, should be 19. And we know in the game 1, it was 14 more points than game 3. So game 3 was 19. 14 more points than that would be 33. Okay, and of course, we can check these. There's one thing we know about these three scores. They have to add to 80. That's what they tell you. So you can go off to the side, say this 33 plus 28 plus 19 add to 80. So we get 9 plus 8 plus 3 is 20. And 2 and 3 is 5. 5 and 2 is 7. Plus 1 more is 80. So yeah, you can make sure you check your totals at the very end of any word problem to see if it actually, makes sense and does what it says it's supposed to do, add 80. There are a variety of ways of solving this problem, so if you do have another way that involves defining a variable, writing an equation, and then solving that equation, those will be accepted. Okay, let's head on to page 3. Alright, perimeter, so all the way around. So one thing about a rectangle, we have to know that if this side is the length of W, so is this side. And if this side is twice W minus 1, then so is this side. The opposite sides are always equal to each other. Okay, so we know the perimeter of this rectangle is 16. So much like the last problem, after we find the length and the width, we can plug them in, and when we add all these sides, they better add up to 16. So here we go. We got all four sides. It's going to be W, okay, plus W minus 1, okay, walking around, plus another W, and plus another W minus 1. And we know it adds up to 16. Okay. By the way, my variable here, they kind of give it to you in the picture, W. W is the width. Just make sure you state that. Let's go ahead and solve. We have W plus 2W, that's 3W. There's 4W. And plus 2 more is 6W. Okay. Negative 1, negative 1, minus 2. And now we can solve. 6W equals 18. And so it looks like our width is 3. Okay. Now, they want us to find the length and the width. We only found the width. So we know the length, though, right here, is 2W minus 1. So our length will equal 2W minus 1. W is 3, so 2 times 3 minus 1, which equals 5. And now check to make sure, does that make sense? Do we get 16 if we walk all the way around? Okay, so we'll have, the lengths will be 5 and 5, and the widths would be 3 and 3. So yeah, 5 plus 3 is 8, plus 5 more, 13, plus 3 more is 16. So yeah, it does add up to the correct perimeter. Okay. So the length of the rectangle we found is 5, and the width is 3. And when we're talking about something realistic like this, we always want to include units. So we do have units here. We don't use it within the equation, but in the conclusion we definitely have to include them. So we're talking about centimeters. So this is a very small box. Very, very small. Alright, next topic, we got relations and functions. Which of the following relations are functions? Okay, so for ordered pairs, we're looking really just at the x values. And do any of the x values repeat? So here you can see, yeah, the first and the last do repeat, so that is not a function. With the graph, you're looking to see, using the vertical line test, does a vertical line at any point cross at more than one point? In this case, the answer is yes. Therefore, no, it's not a function. Be careful with the language. Yes, it crosses 2 or more points. No, it's not a function. So that one's not a function either. Okay, looking at the table here, very similar to the ordered pairs, you're looking only at the x's. Remember, everything relies on the x's. So if you look here, you can see nothing is repeating. Doesn't matter about the y's at all, that they're all the same. So this one is a function. And give the domain in the range, basically take out the repeaters. So our domain, use a brace, will be, I'm going to order these from least to greatest. So we got -3, 0, 3, and 10. And range, without anything repeating, will be -6, then -5, and 7. That's our domain and range. Okay, let's go to number 20. Let's go. Start with graphing. Okay, line A is equal to x plus 3. Line B is half of x. Which of the following are true? Okay, line B is steeper than line A. Okay, steeper, that has to do with slope. The more steep, the bigger the slope. So is the slope of B, 1/2, is that bigger than A? Of course here, since there is no coefficient, the slope is 1. So is 1/2 bigger than 1? That'd be no. So that can't be it. Does line B go up and to the right? Okay, meaning if you graph it. So if we graph that, we'd have to go, since it's rise over run, it's up 1 because it's positive, and it'd be right 1 since it's positive. So when you're graphing, up and right is positive. So yes, line B does go up and to the right. Line A is translated, move up from line B. Okay, so basically saying a translation means this plus 3 moves the whole graph up. So yeah, this graph, since it has a plus 3, will be moved up 3 units from this, which is, since there is no number, it's like a plus 0. Okay. The lines have the same rate of change. And no, we kind of hit on it earlier, but this has a slope of 1, this has a slope of 1/2. And the lines have the same y-intercept. No, we have a y-intercept of 3, and this one has a y-intercept of 0. So just the first two are true. Oh no, sorry, B and C are true. Good. Okay, Marissa went for a bike ride. She rode at a constant speed, and she traveled 7 miles in 1 hour. Okay, Marissa wrote the equation y equals 7x to model her bike ride, where x is the time Marissa spent riding, y is the distance traveled. So graph that equation. So after 1 hour, we had 7. Let's see here. So 1 hour, 7 minutes, which would be right between 6 and 8. And then after 2 hours, you'd be at 14. After 3 hours, you'd be at 21. There would be our graph. Okay. How would the graph change if Marissa traveled a speed of 5 miles in 1 hour? Okay, so 5 miles in 1 hour. 1 hour would be at 5. After 2 hours, we'd be at 10. After 3 hours, it'd be at 15. Right here. 4 hours, it'd be at 20. You can see a slight Slightly different graph. Oh, I see. My point was off. So yeah, slight mistake. As soon as I saw these not line up in a row, something was off. So you can see here I put a 1, 3. So let's try this again. Oops. Okay. So 1, 5. That's right here between 4 and 6. Okay. And 2, 10, and 3, 15. There we go. That looks better. So slightly different. There we go. Okay, so a couple ways of doing this. We graphed it, but you can also see the rate of change went down just by a little bit, went from 7 to 5. Okay, y equals 2. All right, so y equals negative 2. So first of all, y equals negative 2. There is no slope given to you here. Okay, so you have to determine, well, what y-axis, and here's negative 2. What do you do from there? So it's a given that if you don't write there is no slope given. I mean, there's no x here. It's the same as 0x minus 2. We don't write 0x. We just take it off, and that's how come we're left with just y equals negative 2. So it relies on you knowing a little bit of information. And of course, the zero slope is a horizontal line going in both directions. There we go. Alright, that concludes part 1. We'll do part 2 in another video.